Welcome to the fifth video in the series of MCDM technique, that is the multi-criteria decision making analysis. In today's video, we are explore the weighted sum method, also known as the simple additive weightage method. I am excited to share this powerful decision making tool that can help you evaluate options across multiple criteria. Let's dive into it. Again, I am Dr. Architect Parthasarathi Mishra, an associate professor from the Faculty of Architecture, Sri Sri University. So these are the contents of the presentations. Uh, in the beginning, we are going to discuss about the introduction of WSM, then the methodology, third, the case study or some of the examples with some mathematical calculations. Fourthly, advantages and limitations of this particular method. At the end, we'll conclude with the futuristic options that we can do. Now the introductions to the WSM method or weighted sum method. The weighted sum method or WSM is an intuitive decision making techniques that calculates a weighted sum performance rating. What makes it so valuable is its versatility and adaptability across different fields. It allows decision makers to assign the different important weights to criteria, enabling truly comprehensive evaluation systems. So this is the overview. Now the history and development. Let's briefly look into where WSM came from. The method emerged in the 1950s and 60s as part of utility theory when economists were looking for quantitative ways to compare alternatives. Previously it was qualitative, now they are looking for the quantitative way to compare alternatives. Key contributors like Churchman, Ekman and Arnoff helped formalize it, and later Kenny and Refia redefined it further through multi-attribute utility theory. What started as a simple concept has become a cornerstone of modern decision-making method. Uh, Now the applications, various applications. WSM has practical applications across numerous fields. In urban planning, it helps with site selections by weighing factors like accessibility, land cost, and environmental impact. Business use it for supply selections and investment decisions, while healthcare professionals applied it to treatment selections and resource allocations. It also invaluable for environmental management, helping assess the impact of development projects and supporting sustainable decision making process. Now the methodology part. Uh, as its core, As its core, WSM follows two fundamental principles. First, adaptivity and proportionality, meaning the total value of an alternative is the sum of weighted criterion values and changes in criterion values with proportional reflected in the final score. Second, it assumes independence and linear preferences, meaning criteria are independent of each other while a linear preference for criterion value. Step by step process of the WSM method, we have three major steps. First one is the problem definitions, then decision matrix and normalizations, then weight assignment and the scoring, and we can take the final decisions. Let's see into the details. Now let's talk through how to actually apply WSM. The process starts with defining your problem clearly, identifying what decision you need to make, what alternatives you have, and what criteria matters for your decision making process. Next, you establish a decision matrix with alternatives as rows and criteria as columns. Then you normalize this matrix to make all values comparable, typically on a scale of 0 to 1. For beneficial criteria, where higher is better, we divide each values by the maximum value. For cost criteria, where lower is better, we divide the minimum value by each value. Once normalized, we assign weights to each criteria based on their importance, ensuring they sum to 1. Then we calculate weighted normalized rating and sum them up for each alternatives. Finally, we rank the alternatives with the highest score representing the best options. So basically these are the steps for the procedure for the WSM method. You can take the screenshot. It will very much helpful for you in the further uh, research work of your study. Now the mathematical formulations. Now the building, the metrics and weighting data for the final scores. Let's see the detailed mathematical calculations. Let's look at the mathematical formulations more precisely. First, we determine the decision matrix for the parameters across the various alternatives. Then we calculate the normalized data matrix using different formulas for benefit parameters versus cost parameters. Next, calculate the weighted normalized data matrix by multiplying each normalized value by its corresponding criteria weight. The sum of each weighted value gives us our final assessment score for each alternative. The higher this score, we can say, the better is the alternative. Then we can select our best alternative for our whatever purpose we can do. Now let's see with a case example or case study. Let's see WSM in action through a practical example. Imagine an architectural firm evaluating three design concepts for sustainable building, office building. They are considering the construction cost, energy efficiency, aesthetic appeal, and functional space utilizations as their criteria as C1, C2, C3, and C4. Whereas we can say we have three design alternatives like design A, B, and C. So step 1, we have defined our problems with three alternatives and four criteria. Step 2, we establish our decision making showing how its design performs on each criteria. All the criteria on row 1, whereas all the designs alternatives are in column 1. So lower the values are preferred for C1 and C2 as they are the cost criteria, where higher values are preferred for C3 and C4. Then we can say these are the beneficial criteria for us. For example, in our case construction cost and energy efficiency, we can say the lower the value, they are the best for us. So that's why these are known as the cost criteria, and other two variables are known as the uh, beneficial criteria. Now step 3, we normalize these values for cross criteria like construction cost and energy usage. We use the minimum values divided by each value. For benefit criteria like aesthetics and functionality, we divide each values by the minimum values. So in step 4, we assign weights to our criteria based on their importance. And the cost criteria is like 0.35 or 35%, energy efficiency at 25%, aesthetic at 15%, and functionality as 25%. So these weights we can get from different methods like AHP, which we have already discussed in the previous presentations. Then fuzzy logic also one of the method. So we can adopt any of the method for getting the weights of the parameters. Now step 5 and 6, we calculated the weighted normalized values and total scores by multiplying each normalized value by its weights and summing across criteria. Next is the step 7. Finally, we rank our alternatives and find out design C scores highest at 0.923, followed by design A at 0.889 and design B at 0.888. So we can say and design C is the best solutions. Now looking at the results and discussion, we can say design C achieved the highest score primarily due to its excellent functional space utilizations. Interestingly, the small differences between score of other designs highlight that they perform nearly evaluated overall just with the different strengths. uh, this case demonstrates how effectively WSM can balance completing criteria and guide decision making through a complex evaluation systems. So before Previously it was like qualitatively, now we can make it as a quantitative assessment sort of things. Now we can look forward to the advantages and disadvantages or limitations of this WSM's method. WSM offers several significant advantages. First, its simplicity and transparency. The straightforward calculations process make it easy to understand and explain to stakeholders. Second, it offers the flexibility and efficiency. The method can be applied to various problems with different criteria, is highly customizable. We can make it as per our preferences and require minimum computational losses. So mainly this WSM method, we can use it through the software tools like Microsoft Excel. This is the best tools. Now, however, WSM does have some limitations to be aware of. It assumes criteria independence and linear preference, which may not be always hold true in real-world scenarios. It also sensitive to criteria scaling, and higher performance in one criteria can sometimes mask poor performance in other. Additionally, the results can be influenced by the units used to measure criteria, and the method primarily designed for quantitative criteria. Through qualitative assessment, aspects can be converted, like quantitative, some of the parameters may have qualitative uh, values. Now converting the qualitative parameters into quantitative values, some of the time they have some biasness. Another concern is ranking sensitivity. Um, Adding or removing alternatives can affect the ranking of the existing options. Suppose we are adding one or two criteria in the list of the parameters, then it is always uh, the results can be vary. Like option one, right now the uh, design C is better. If you'll add one or two parameters, then design A will be better. So it is always a concern when we are selecting the parameters, so it is always better. So we have to find out which of the parameters are mainly concerns to selection of the alternatives, that is most important. Next is the dependency and preference constants, unit and criterion limitations. As I told you, we have to uh, in this process we are always making the normalized data matrix where we are removing all the units. So while removing all the units, sometimes it is problematic while calculating, and we have some kind of ranking sensitivity. As I told you, when we are adding or removing one of the two parameters, maybe the final results will may vary. So these are the two limitations majorly. Now the conclusion. To summarize, WSM is a valuable multi-criteria decision-making method that combines performance rating across different criteria through weighted additions. Despite some limitations, it has proven effective across various fields and applications. Uh, Now, looking forward, there are exciting possibility for enhancing WSM. Research could focus on integrating with fuzzy logic to better handle uncertainty and imprecisions. Developing adaptive weighted methods could help it adjust to changing constants, making it more robust in dynamic environments. And exploring hybrid approaches that combine WSMs with other decision-making techniques could address its limitations and offer more comprehensive tools. So thank you for watching this explorations of the WSM method. I hope you have gained valuable insights into this powerful decision making tool. If you have found this helpful, please like and subscribe for more content on decision analysis methods. Along with that, I have another playlist of the guest lectures that you can also see. Drop your questions in the comment box. So, and thank you. I'll see you in the next video. Thank you for now.